Aper in 1795 took on the project.
It took almost 15 years, but Nicholas Aper was successful. He partially cooked food, put it in a glass container, corked it, and then boiled the bottle. Englishman Peter Durand had a different idea. He started working with metal instead of glass in the early 1800s.
And he figured out a way to use the metal can as opposed to glass, doing basically the same process, but the metal can was much more durable, it didn't break, and the result was that Durand's process was much more sterile and had more longevity.
Durand combated rust buildup in his iron cans with a tin lining that protected the food. He then soldered on a lid after the can was filled. That was the dawn of the tin can. Durand's innovations soon found many practical applications, including the preservation of fruit and vegetables, which could now retain their vital nutritional value. Scurvy, which had been the bane of many an English seaman, ended. Sailors who had once starved for nutrients could now withstand long voyages. By the time of the American Civil War, Union soldiers relied on canned food for survival almost as much as gunpowder.
It became something that allowed civilization to do things other than just forage for their food. So the preservation of food in a safe manner allowed them to begin to do other things. And, you know, that was really the beginning of industrialization.
In the decades to follow, automation caused the tin can industry to flourish. During the Second World War, the can's value became deeply rooted in the minds of American GIs.
2/3 of the food served to the soldiers in the Second World War was canned food. And then they came home, and families were dispersing and going elsewhere, and the result was that they had a real confidence in canned food.
In the post-war era, food in a can became a staple in every home and propelled the industry forward.
In North America, today we process 33.5 to 34 billion cans of food every single year. The metal container has been threatened by other forms of packaging, plastic and flexible packaging and things like that. And I can honestly tell you that I've seen the obituary written for the metal can several times. But when all is said and done, the metal container is still going to survive.
While the metal can may hold the distinction as the world's most important container, another can with a clever innovation nearly eclipsed its importance: the aerosol can. The aerosol can came into its own in the 1940s. Again, war proved to be the impetus for significant innovation. The U.S. government funded research for a portable container that soldiers could easily carry and use to spray disease-carrying insects. This device proved invaluable for the troops in the Pacific Theater, where malaria was rampant. This insecticide spray is credited with saving thousands of soldiers' lives. The proven success of the aerosol can in war soon expanded to the home front, where families applied everything from hairspray to medicine with increasing ease. An aerosol can is made of steel or aluminum and works with the use of a propellant. The propellant is a gas. When the nozzle at the top is depressed, the force of the gas pushing down on the product causes it to move through the dip tube and finally exit the nozzle. The narrow nozzle atomizes the liquid and forms a fine mist. Early aerosol cans used liquefied gas that contained chlorofluorocarbons, or CFCs. But scientists discovered that CFCs cause detrimental effects on the ozone layer. They were removed from more than 90% of all aerosols in the U.S. by 1978. In the 1980s, CFCs were banned worldwide, but manufacturers soon devised harmless propellants. Today's aerosol industry manufactures over 3 billion containers each year. And although the can sealed its place in society, a resealable plastic container put the lid on fresh food, changing our kitchens forever. A sealed tin container of roasted veal from one of Sir William Parry's Arctic expeditions in the 1820s was opened in 1938. The contents were then fed to a cat with no ill effects. Containers will return on Modern Marvels. We now return to containers on Modern Marvels. In In the United States, 36 billion glass containers are produced per year. They'll hold everything from baby food to pickles. At the OI factory in Vernon, California, they make 1 million glass bottles a day. The 6-step manufacturing process starts with raw materials.
This is the batch house facility. As you can see, there's a number of silos here where we store our raw materials. Silica sand, limestone, soda ash, and hullet, which is our recycled glass. And within this facility, we weigh it, we mix it, and we then deliver to the furnaces via a conveyor system.
The fiery furnace that is approximately 5 feet deep converts the raw materials into molten glass.
This furnace consists of high-temperature ceramic bricks of many different sizes and shapes and weights. It contains about 500 tons of molten glass at about 2,800 degrees.
After the glass is melted in the furnace, it's delivered to the forming machine. The molten glass gets sheared into uniform pieces called gobs, and then blown into the mold shape with compressed air. The glass enters the forming machine at 2,100 degrees Fahrenheit. Formed glass containers leave the machine at 900 degrees Fahrenheit in less than 10 seconds. This rapid cooling helps the glass retain its shape. The extreme change in temperature can cause stress in the bottles if they're not cooled properly. Therefore, the formed containers are loaded into an annealing leer, where their temperature is raised to 1,000 degrees, then reduced gradually to below 200 degrees. This reheating and slow cooling eliminates the stress in the containers, making them stronger and more shock resistant.
After the annealing process is complete and the bottles have cooled down to about 200 degrees Fahrenheit, we apply a coating on the outside of the bottle. The coating protects the bottles against abrasion and scratches, thereby enhancing the strength characteristics of the container.
Each bottle is inspected. Those that don't pass get sent back to the fire.
After inspection, some of our bottles are bulk palletized rather than being put into cartons. This machine right here puts our bottles on top of a pallet 9 layers high. We then strap them to the pallet in preparation for shipment to the customer.
The highly mechanized system that runs 24/7 in over 81 OI plants worldwide turn raw materials into billions of transparent, strong containers a year. It's taken glassmakers thousands of years to reach this level of speed and efficiency. Around 1500 BC, Egyptian craftsmen developed a method for producing the first glass pots by dipping a core mold of compacted sand into molten glass and then turning the mold so that the glass adhered to it. While still soft, the glass-covered mold was rolled on a slab of stone in order to smooth or decorate it. Then, sometime between 27 BC and 14 AD in Syria, the blowing of glass transformed glass container making. Glass blowing has basically remained unchanged. Once the glass is heated into a semi-liquid, it's placed at the end of a rod called a punty. The glass blower then blows into the punty to shape the glass into different formed containers. By 1880, more than 25% of the glass made in America was used for common bottles that were arduously blown one at a time. In 1903, all that changed with an invention by a young glassblower from Ohio.
The first fully automatic bottle machine invented by Mike Owens would make